Please like and leave a heart. Please.
There we go.
Hello, everybody, and welcome to the Beagle Locksmith Show. I'm your host, David Gibson, where we are unlocking the secrets to success in the oil and gas industry. One interview, one technical presentation, one technical screw at a time. Thank you guys all so much for being here on this amazing Friday. The first show of the 2025 season. It's going to be an absolutely amazing year. We're going to have a lot of really great episodes. We've already got stuff already booked out all the way through, I think, mid-February. Is that right? Or March?
March 14th.
Oh, March 14th, yeah. So we've already got stuff already booked out through March 14th. Maybe we'll post that on LinkedIn or send out the email here pretty shortly so that you guys can start setting your calendars to be able to tune in on some of the amazing episodes that we've got coming up. Just to let you guys know, we don't have a sponsor for today's show. So if your company is interested in sponsoring the show, feel free to reach out to myself or to Tracy, who's behind the camera and the computer today running everything. So
He said bad echo.
Bad echo. Why would that be? All right. Technical problem of the day.
Let's turn that one off so it's not audio follows camera. It's audio follows that one. That's probably the problem. So echo. Is that an echo, bad echo? You know, actually having audio problems is what helps drive the algorithm because then it causes everybody to comment in the comment section. So, well, at least we've already got a couple of people watching. We give a shout out to a couple of people. Yeah, let us know where you're watching from. I forget some of my usual things here to say. So we've got who we got tuned in. As always, Mr. John DeWart. Good morning from freezing cold, sunny Elkhart Lake, Wisconsin. Absolutely amazing to have him here. Then Eric tuning in from sunny south of France, as usual. Anybody else tuning in? All good now. Adonis. All right. I need to get in touch with him. We need to do, if anybody's interested, and I think this one might be the easiest one to do, we might be doing a kind of like we did the torque and drag series, but one on casing design, and everything else that goes along with that. I need to get in touch with Adonis for that. Oh, John says, all now clear. All right, here we go. But David, if you record with a phone, just turn the mic off. Definitely not using a phone for this. We've got a GoPro and then my Lumix GH5 camera, just in case anybody wants to buy one. I've had a handful of people ask me why I'm so clear in my webcam meetings. That's why I bought a really nice camera. Mr. Lord Bailey Midgift tuning in. Good morning from Wyoming. Funny story. So Bailey, he bought one of those things in Scotland. If you own land, you become a lord. So he's got one of those like tiny little plots, and I've got one too that's sitting right there behind our guest of the day. So I don't call myself Lord though just yet, but Bailey went full send on it, and I think it's hilarious to be able to do. So then we got John tuning in, following from San Antonio, Texas. Thanks for being here, sir. Do appreciate it. All right, so today, guys, if you will, put into the comment section hashtag Gibson. Maybe that's what we'll do. And then you will be entered in for a chance to be able to win one of the amazing 3D printed drill bits. We've got a handful more sitting over there. I don't know. Maybe at some point in time we'll give away another one of the big ones that we've got here. So if you maybe, I don't know, if we get over, I don't know, however many comments today or something, if we get a bunch, people ask a lot of questions, then we'll give away the big one. So be active in the comment section. You guys talk to each other. Not giving away my my little 3D printed Lego guy just yet, but we might even do that at some point in time. So, all right, who else we got tuned in? So Michael says, howdy from Abu Dhabi. All right, love it when it's an international show. I think that's it for me. Nothing much really to say. Coming up or anything. So that's it. All right. We'll welcome our guest of the day. Second time here on the show, Mr.
Actually,
George.
it's the third.
What? Yeah. So
hit him when he's not looking.
So there's a little bit of contention on me with that one because it was during COVID. So the first one was at the old set when you
Mhm.
came in, and you were like, you were probably the first, I don't know, like 20 or 30 people that came on the show. And that was due to my neighbor in here that you've met, Rick, who's essentially my mentor now. Told me, he was like, man, there's this really, really smart guy. You got to get him to come on the show. He's like,
Who was that?
And so then the second episode that I wanted to do with you, I wanted to have you on my show, but then I defaulted to SPE and said, hey, this might be helpful to y'all. Why don't we do it through SPE instead of just through Gibson Reports and the Vidor Locksmith? And so I gifted that episode to them, essentially, knowing that it was going to be a really good episode and everything. And so that it was one of those things I look back on. I was like, maybe I should have kept that one to myself, so that it would have been in the Vidor Locksmith catalog as opposed to being owned by SPE. But yes, thank you for coming back on the show. I do appreciate it. For anybody who hasn't watched the first episode, go back and check that one out. That one's really about, the viewpoint of, what a completions individual looks for from the drilling department. And we played the little clip yesterday. You said, one of your top 10 things that you're looking for, and record well is not on that list.
Don't want to see it.
Do you still do you even get on LinkedIn? Do you see any of the stuff on there?
Yeah.
Okay. So do you see the record well stuff still posted?
I do. I kind of have a good chuckle at it because it is fantastic to set records, but what are you leaving in that well? Have you turned it too fast? Or turned it into a little bit of a problem for somebody else down the well or down the way? And it's nice to have that record, but if it makes you really pick up a workover rig and try to get in there and fix something afterwards, then I would rather see a really good completion where I have a lot of uptime and a minimum of repairs afterwards. And you don't always see that with record wells.
So I want to touch on something that we were talking about before the show started, and I laughed really hard at this one. And you'd said that workovers is the most fun you can have in the industry.
Oh, absolutely.
And
it's the unknown.
And it still kind of boggles my mind to think of that.
Think of it this way. You're 1 to 5+ miles away from what you're working with. You don't have a record of exactly what happened. All you know is something's wrong. And now you don't have all the data you need. You don't have all the even structural information you need. You sure don't have the rock properties. How are you going to form an idea of how to go forward? Well, you have to have an imagination here that says, I think I'll guess on this because this happened and this happened and this happened under these conditions. You put that together, and it's your imagination which really runs a workover design for some of the most successful people I've been around.
Well, I mean, I can see that. Maybe we need to get some of our kids to be able to go out with us on workover operations, because their imagination will probably be the best.
Actually, you're kidding about that, but when I was at BP and we were trying to come up with some new ideas for designs, Crazy Horse being one of those, turned into something a little bit different. I asked a bunch of people to come in, and my task was just get the drillers some new ideas, the well designers. And I asked a couple of people that were really smart scientists, but they didn't work at all in the oil industry. I asked them to come in, listen, and give us a suggestion. And we actually got one really fantastic suggestion out of that. I can't tell you what it is because there were some patent rights, but nonetheless, it worked. And this was she didn't know anything about it. It was a lady that I knew that was just sharp as a razor. But she came in there and she gave us an idea that we could go forward with.
Oh, wow.
The other thing I learned,
Leave us on the cliffhanger there.
the other thing I learned about that type of new response or a better response is a meeting that's in mass chaos with everybody slapping out ideas, just brainstorming. That is oftentimes the best place to get good ideas. But you got to put up with a lot of chaos.
I'm willing to put up with the chaos. It's just getting people to be able to feel comfortable in a situation like that where they can just throw out ideas.
Alcohol helps.
So you don't have these meetings at the office, is what you're saying.
Yeah, you shouldn't. The best way to get new information isn't to have a spy or anything else. It's just take them out and buy them a couple of beers.
Or build the bar at the house, right?
Or you can do that.
All right, before we get too far off topic with it, we already got a question there from Robert. What would you expect to find more surprises in workover wells or rank wildcats?
Oh, that would be tied because workovers generally, unless it's the first one of its kind in a field, they're reflections of what's going to happen in that field. Wildcats, would compare to an initial workover somewhere and you have no information. And wildcat is you probably just put your blinders on and just drill ahead and try to get what you need from what happened and work backwards. But it's hard to work backwards when it's an explosion because everything is all blown up. Same thing, even when there's not propellants or state or type 1 explosives used, it's something that happens, and we're working with the pressures and the temperatures and some of the loads in there that something could happen, and you've got a 37 car pile up, but you don't know what exactly caused it. Takes a while.
Like finding 2 wireline tools in the hole.
Yeah, something like that.
All right.
Total mysteries.
I can only imagine just going in and going, what, how did these get here? Now, I mean, I'm guessing how often is like that craziness kind of happened where, because a lot of wells are essentially, it wasn't something that was in, BP or Amoco's or whomever's portfolio in the beginning. It was, hey, we bought this field.
Sure.
And then, we got turned over all of this, we got the data room stuff turned over to us, but, that could be incomplete and whatnot. So how do you go about addressing that? Like how does, because you got to go out there and do something to them. Is it just, all right, well, let's go see.
Well, first, you got to get a hold of the field foreman and get on their good side. Maybe buy them a beer or lunch. And
we're circling back to what we said a minute ago.
Yep. And basically, the field people know far more about issues that are happening in the field than an engineer sitting in the office. And this is one of the reasons I got to thinking about this over Christmas when the house was full of kids and I kind of closeted myself in my office. And I thought, out of mass pandemonium, who are you going to ask in terms of what I should do next on a well? Well, it'd probably be the senior field foreman who's been there in that well or in that field for a long time working for that company, because they're the ones that apply the jobs. Now, what I got to worrying about was how do you pass that knowledge along? So training 101 to 106 for field people, you got a new person coming in, maybe experience in another place, maybe not, but he's coming in. How do they learn the best things that they can do to, number one, avoid a problem. Number two, quickly recover from a problem. How to fix it both quickly and inexpensively. And finally, how to not have problems with that well again, leaks, failures, anything else. What your final goal is in the field is how much uptime will that well give me? You get a well that gives you over 90% uptime, and that is a measuring stick of what you could look for. Now, if the well is only up 40, 50, 60% of the time, you're losing a fortune. And if you don't know why it's not up, and it's generally lift or some other thing that could be taken care of, if your field crew knew exactly what to look for and what to do. And that was something that comes to you from experience. Now, I'm not a field foreman, but I've been out in the field a huge amount of the time that I was with Amoco. And a good bit of the time when I was at BP, I was up on the North Slope, just sitting in wireline trucks for 100 hours or more, not straight, but a lot of time.
I'll believe you. You could say it. I'll still believe you.
Well, you say it and I'll swear to it. Anyway, the things you're doing there is you're learning what they're doing. When I was sitting in a wireline truck up on the North Slope, I was learning messages of how not to break wire, how not to get stuck, how not to have the grease seals in your well on your lubricator go bad, how not to leave a lot of wireline grease in your hole, which, by the way, is tough to get out, and especially when it smears all over your formations, because there's not many really good solvents that you could actually use today. So those are the things you're learning, and the tool type. Well, look at the tool. Is it a worn out tool? Is it has the sharp edges? Can it still catch the collar in there, or the flange that goes on some of these tools? That's what you're learning. I put that in a training deal, put it out, and it did make a difference in several areas where we were having wireline problems. I mean, North Slope was running 7 or 8 wireline trucks 24 hours a day. I asked the guy that was running in charge of the whole thing, I said, well, how often do you break wire? He said, we broke wire once about 18 months ago. When's the last time you got stuck? He said, about that same time, but we don't get stuck. We've got the procedures we follow of you can only impact down, jar down 150 times or jar up 150 times. You come out, you strip off some wire, rehead, you go back in. This takes care of wire fatigue. He's looking at, is there H2S in that well? There's a lot of things you're looking at that senior guy out there knows. How do you transfer that? Sitting in a class isn't usually what a field foreman will want to do.
No.
But you've got to pass on the mechanics and the knowledge, sometimes chemicals. You're working with paraffin, asphaltenes, all kinds of scales. Well, those things are going to be happening every day. How do you control them? How do you minimize them? Is it better to prevent them than it is to remove them? Or is it cheaper just to wait until it forms and then remove it? And how do you do it? All of those things add up into a huge pile of knowledge. How do you transfer it?
That's a really, it's a good question for the industry itself.
It is. But some probably have training programs. I know a few that do. And a lot of times it's just, well, that guy over there has really good knowledge, and I'll just offer him more money. He'll come to work for me. And that may be one, but you still got only one guy out there.
Yeah, you can only do that so many times.
You can only do that so many times, and that's very, very true. So how do you do all of that? And I'm not saying that I'm not offering any program or training deal here up here. I'm leaving that alone. I just want to see the industry develop some of these things that is really useful at passing that information on. Because every time that we don't have the right people out there that don't know that you can't use a certain kind of sealant as a on the seals of a plug, because at some temperature or with some chemical that's coming in there, it's going to fail, and then you've got a blowout potential. Let's get that taken care of where we can get safer out there. We can get more environmentally friendly. Basically, what I want to do is let's keep our names and events out of the papers or the news media. Signal, you don't get papers much anymore. The morning paper.
Well, I miss still.
It. I miss the crossword puzzles and the funnies. That's what I turned to first. But this is just kind of I got on my hobby horse, and that's what I'm doing.
So a call to action to the industry to be able to,
or at least to say we already have that, so shut up.
Yeah. Well, I mean, I think it's one of those things to where one of the things that I've learned from working with Rick, and things that I've learned from, many times with people here on the show, is that, they'll go out to the field and they'll learn something from the guy that's out there doing it all the time. And he goes, yeah. It's like, because sometimes, pumpers, gaugers, even of that nature, they're working for multiple different operators. Sure. And they could look at you and go, wouldn't do that. Okay. Guys across the street paid me to do it, and it went all wrong. And they've learned those lessons. So it's being able to.
That brings a funny. I was just breaking into the Barnett Shale, and I had never designed a frac job for a shale. And I watched the first one I set in on, and I'm going, this isn't right. Because they hammered that frac, they just hit that frac, it went down right through the barrier below it and into the water, and that well came on at a little bit of gas and 500 barrels of water a day. So
I think I had one of those happen to me.
Yeah, and so the next time and I didn't design that frac, but I got called on to do one, and so I go out there, and I had gotten my spreadsheet out, the engineer's fallback, got my spreadsheet out, walked in the pump van, brought some tacos with me, and passed those out, and I said, hey, I have never really designed a frac job for a shale. Have you got any suggestions? I had mine all out, and this guy, this pumper, I won't tell you the name of the pumping guy or the pumping system. He grabs, well, here's what X has done it, here's the way Y has done it, and here's the way Z has done it, and don't do that one. And basically he said, I can't let you take them home, but I can let you look at them. I looked at all that. I said, well, let me make a couple of changes here. And pretty soon we came up with a very good frac design for it. I never used a computer on that one. I just don't think a computer can be effective in a new well without any background information, because you're going by estimates, averages, and sometimes wild guesses. And if a computer spits it out, a lot of people believe it, and I'm going, I want to know when the pressure does this, what's happening down there, the loading, the temperature, all of those things. I'm trying to figure it out, but you've got to sit in the frac van to learn that. The same thing on a workover. You've got a procedure coming out from headquarters, but a good field foreman is going to look at that and says, we can't do that. We've got to change a little bit here. And they'll tell you that, oh yeah, pumped it or did it as prescribed, and you don't know what's going on unless you were out there watching.
Yeah.
And nobody's trying to fool anybody. It's just like some of the field people were a whole lot better at doing that than the engineers that were designing it. It's a little embarrassing at times, being as I'm an engineer.
Well, they do say that there's practitioners And then after practitioners come the scientists or whatever that prove out what the practitioners are already doing.
Yeah. And on a job, are you looking for the answer or are you looking for the solution to this so we can get the well back online? You're generally looking for the solution. Leave it to the sharp people, the engineers that have got some time to work on this and figure out why it worked or why it didn't, or you can just try it. Now, as long as you can control everything, no blowouts, no accidents, all of those things, that is a viable approach. But it's really better in the hands of somebody who has done a lot of those jobs before, whether it's fishing, whether it's perforating in a hot well. There's a dozen different things. Experience in the field is what makes that successful. Now, how can we improve that and get it to more people? That's what I want to see the industry move towards, is not just labeling somebody, like this is a class, you got to sit in this class. Well, field foreman then going to want to sit in a class most of the time, most of the ones I know, and put it out in the field and give some demonstrations, let people see what's going on, give them the reason why you're doing that. And we had a chance to do that when I was with Amoco. I was with Amoco 28 years and then BP for 9, and then a couple of things after that. I've been in almost 54 years now. But what I found was Amoco gave me some money and said, hold a technology applications meeting. And we call people in from the field. We had some field engineers, but at least of 20% had to be field foremen, bringing in what went wrong with their well and how they solved it. And that is still some of the best information transfer that I've ever seen that would happen in the classroom or in a meeting room. And everybody, they were from all over Amoco, and we had a 2-hour lunch. It wasn't to kill time. Go to lunch and you get these conversations started. And I've had people come up to me years after the last one of these things that we did, and they said, that works. Because a field foreman is listening to another field foreman who says, I can do this. Here's how I do it. And this other field foreman is going, if he can do it, I can do it. Neither one of us have a college degree, but why does that matter? You got the job done.
Yeah. You let somebody else sort out later on why it worked. And why
sometimes
the solution was.
Well, sometimes the field foreman can tell you why, and sometimes they can't, but they got the well back online, which was the objective anyway.
I mean that obviously makes sense. That is a. I wonder how many companies could implement something like that tomorrow. Just being able to get their field foreman in the same room and letting them.
It depends how rigid the red tape barrier is. In terms of, okay, we're going to bring somebody in, we'll let them shadow with this experienced guy. That works for a little bit, but you've only got them talking to one guy. Well, or a person rather. Couldn't say a guy. I've known women field foremen as well who are good. Now, you do that, they need to see across the field how to do that. And that becomes very difficult to have every person just doing that, going to every field. There ought to be examples, maybe videos that you make a field foreman doing something like that and then passing that along within the company or on the outside. There's ways to do this, but it's company specific as to who is going to take that banner or that baton and run with it. Who's going to try that? So I'd really like to hear back from some of the people who are doing that type of a situation. Let me give you an example. One of the best successful workover people I've ever known was out in West Texas, and he would look at a procedure that was coming through out. He'd look through that first. Is this feasible and possible to do? Has some engineer with not too much education in mechanics or how fluids work in the field, is this possible? Okay, if it's possible. The next column was, what is the risk that I'm running? Could I get stuck? Could the casing collapse? Could the wire break? Anything to do. And he would put that down in, okay, this could do this and this and this, and I don't want them to do that. But if they do, what is the tool I need? And where is that tool? If you needed a specialized fishing cup or a fishing tool, who has it? Is it 500 miles away or is it 5 miles away? All right. Next column. What's the best person out there to have on location as this is being done? Interestingly enough, this guy had about a 10-year record of doing this with the fewest problems and the quickest turnaround to get the well back online of any of the field people that I know. He also made a fortune investing in Walmart when it was first coming out.
So obviously a very smart individual.
Yes. Yeah, he retired quite well.
Well, I want to jump back to you were talking about fracking and stuff, and we don't want to go too much into it, but I wanted you to talk about being able to notice problems and stuff early on and how to identify, something to where it might be going south.
Okay. I'm going to jump back into the casing problems that we have during fracturing.
Okay.
And I did quite a bit of that. And basically the red flags that would come up, and in my training that I have off online, I have some red flags in there of, when this happens, beware of what might be the downside of it. And this is an example. You have a design of how the well is put in the rock, and any time you pass a transition zone, you have a layer, and then there's a transition zone and then another layer. Anytime you pass through that layer, that is a red flag for having a problem there, because the stresses, the material, and even the consolidation in that transition zone can be entirely different. And so that may not be well supported by cement, or it may be something, okay, you've drilled in and maybe a little bit of that, the lower one moves when the upper layer doesn't. That's an area where we found problems. So watch those transition areas and look for those ahead of time. That's where I would avoid perforating in that particular area for about maybe 100 feet either direction. That's particularly if you knew that that is not a stuck tight connection between that upper rock and the lower rock. Other things are, there's 1,000 of those. You can look at different types of casing that you have, the design of the casing, and that's all done on computer, but the computer is taking averages, which is all you have of rock properties, and putting that in as stresses. So the more you know about the geomechanics, rock mechanics, the better off you are. If you don't know any of that, and this is a wildcat well going through there, that transition, I'd avoid it like crazy until you know more about it. So those things are problematic. You get onto the production side, watch the chemical analysis of the fluids that you are producing. If you see iron going up or chrome going up, if you're using chrome pipe, you're getting corrosion there, and corrosion is increasing. use that as a trend and you can see problems coming. So a lot of things, chemical, or let's even take one further. Where are you seeing scales, asphaltenes, and paraffin? Normally you see paraffin at the top of the hole, you know, around the wellhead or something like that, and then it progressively gets deeper. Scale can be exactly opposite because of how it is actually transferred out there. And of course, paraffin is dropping out because two things: it's cooling off, and gases, light-end gases that keep it in solution, are being flashed off. So you're going to have more paraffin in there. Do you need to hold a little bit more back pressure on it? And some of this comes back to choke behavior, or maybe the size of the tubulars, or how often you're treating that paraffin and how to treat it. I mean, if it's shallow, you could probably do it with hot oiling. When it's deep, don't forget about hot oiling. You can't get hot oil down that far, especially if you're allowing it to transfer up you're circulating and transferring up the annulus. That's a shell and tube heat exchanger. You won't get that heat less than about any deeper than about 100 feet. I did a field study on this. That's another thing Amoco always let me do, is fiddle around with field projects. It was fun.
I'm glad they did.
Yeah. Most of the time it turned out productive. Sometimes it didn't. But if you're not making mistakes, you're not pushing the envelope. So all of that is, you're looking for things that would explain the scales and the paraffins and the asphaltenes and the corrosion especially, and sometimes the deformation. Deformations will be rare compared to the presence of that asphaltene, paraffin, and scale. But that's a behavioral deal. Somebody has got to be looking at the analysis of that. Sometimes an engineer will do that. Sometimes you don't have that many engineers. I know companies have cut back quite a bit, but I would like to see, you know, the field foreman and the engineers really working together very closely. But a lot of the times, field foreman will come up with some fantastic ideas that basically these are the heroes of innovation or invention in the oil field. Some of these inventions are crazy, but they work. All right. But they're right out there at the coalface. They've seen it happen every day. Don't be surprised when a field foreman can actually see, I say, you're going to have problems with this well because this well and this well next to it had the problems at about the same stage. Pressure loss, water influx, all of these things. Look at it. So, you know, it's fun being out in the field. Sometimes you think you're wasting time with all the truck travel that you have to do.
Yeah.
But what you see out there, if we can capture that and move that along in training, I think we would be a lot better off.
Excellent. I know we got a couple of questions in there. What was Eric's there? Is there a way to pass that wisdom on outside of mentoring, and can that be done differently in our digital workspace?
I think it can, but you're going to have to make an effort to get the field foreman to actually talk. Most of the really good things that I've seen coming out of the field that a field foreman developed are siloed. They don't go any further. And when I did this deal with Amoco, we had field foremen from Louisiana talking to field foremen from West Texas, talking to field foremen from Colorado, all of those places. And they many times had similar problems, but different approaches to solving the problem. And that gathering of field people to talk, that organized gathering about, okay, to come to this meeting, you got to bring your problem or your train wreck. And that's what BP did. Not BP, but Apache did when I was working for them. They would have a train wreck session. The drillers put this on. To get into that room to take part, you had to bring your own train wreck. and say, okay, this is my train wreck. This is what happened. And this is how we got it fixed. Or in the case, tell me what your ideas are to fix it. And you got conversations going. That worked. It really worked.
I mean, somebody could probably start hosting those right now. It's like your admittance to the room is the train wreck.
Yeah. But SPE has one really big flaw. We don't talk about failures unless they've already been solved.
You can't say the F word. Yeah.
Yeah. You can't say the F word, the failure work. All right. And that's true up to a point. Now, some other ones like NACE, a National Association of Corrosion Engineers, man, reporting disasters and problems, that's their forte. And people learn from that. They see the accident, you describe what happened to it, and there's not an axe hanging over your head from management up above. So there's ways to do it, but we're going to have to change some of the way we, some things that we do when you have a failure. Any company that says no failures tolerated, I don't want to work with. Because I've had a bunch of failures, but I've learned a bunch from it, and some of them became successes afterwards.
I was even thinking about this the other day, that maybe your resume doesn't just highlight all the things you've done right, but then you could list out, like, here are all the big problems that I've had. You know, here were some of my big failure points. You know,
I would trust a person who was willing to do that far more than I trust somebody who was only polishing everything they did.
might be a new trend. Everybody changing the way they write their resumes and stuff. Who knows?
Well, if you can describe your problem and tell people how you fixed the problem, that's going to mean a lot, because you can actually admit you had a problem and you fixed it. You don't want people that hide their problems. If you don't do a post-mortem on failures, you're not going to learn anything.
Very true. Very true. I know we got a couple of more questions in there. Something tells me video series with a field foreman would require too many audio edits.
Now, if you're just showing it to field foreman, I don't think they care.
Well, if you bleeped everything out, then maybe the other field foreman wouldn't be able to understand it. You have to speak their language. Put engineers in the field for 3 months with lease operators and 3 months with field foremen, from Mr. Scott Hines.
I agree with that 100%, although I think it needs to be 6 months.
I'd love to get you and Scott together. You two would be two little peas in a pod.
Well, first job at Amoco after they hired me, and I was a lab assistant for a couple of years there. And then they started sending me out to the field. I learned more from field foremen than I ever learned sitting in a college class, because my style of learning is I need to see it and I need to have hands-on, or talk to somebody who had hands-on, because you find out a lot more in that particular case. But again, what's your objective? And in what we do in field work, it comes back to how much can you keep that well online. You go over 90%, you're doing a pretty darn good job. If you're down 70, 80%, what's causing it? Well, is it paraffin, asphaltenes, scale, or some other problem? And the biggest thing that a field foreman really needs to look at is knowing how the lift system works and how to spot problems, gas interference, rod pound, running it too long, running it too short. If they understand those basics, and that can be taught in a pretty good little course, but it has to be practiced in the field to learn. Difference between being taught and actually learning it. And you got to figure out, some people can just read a technical paper and they learn. I've got to read a technical paper line by line and then make a PowerPoint presentation out of it, even if it's not my work. Make a PowerPoint presentation that explains all of the details, and at the end of it you say, oh, now I understand it. Well, that's why I've got 14,000 PowerPoint slides. You know, I'm not kidding. I did.
God, well, there's
I've been doing it for
there's the
years.
treasure trove that the industry needs.
Well, some of these I can't even show people because they are from inside companies. But you know, buy me a beer and I'll tell you about them.
Buy your beer. I just want the copy. I just want a thumb drive with all that.
Well, and if you, I put a lot of my training, and I had 200 PowerPoint presentations on the web at one time for free download until my host on the deal just absolutely started blowing them off and canceled it. And so I put them on for training and made training courses out of them on the web for Saga Wisdom up in Canada. And they, you know, it's by subscription to any kind of company or individual that wants that. But if you're looking for something that's unusual, that I probably have slides on it. I mean, I have slides on how to freeze a wellhead. That's a good one. When you haven't got any other controls, like the one we were doing was we had a perforating gun that didn't fire, brought it up to the top, and it brought a pipe fish along with it, caught it, brought it up into the head, stuck it in the wellhead. And we discovered that the perforating gun had not gone off, and it was a drop bar system. The bar was still sitting on the initiator up at the top. And so they froze. They put a 55-gallon barrel, split it on one side, put it around it, caulked it in, filled it full of alcohol and dry ice, and froze everything to where they could back it off, get that tool out of there, back it off, and then get the gun out of there and go back. Yeah, there's some things that'll scare you to death that we've done out there that you don't want out in the public, but it's been done. And I was nosy enough and curious enough to get the data on it and see what the heck you did.
It's one of those things you say something like that, and to me, it thinks that I in my brain, I'm imagining my tool chest, you know, in my garage, right? And there's typical, you know, open-ended box wrenches, screwdrivers, sockets, and stuff for the regular stuff.
Mm-hmm.
But then I'll have a couple of things that have to go in the miscellaneous drawer that it's a tool for one specific thing, and that's all it's used for. But the whole reason I spent the $30 or $40 on it is because if you don't have that, it's just like, it's hell. It's absolute hell to pay to try to do whatever that task is without that thing. But if you've got that thing, you know, you use it once in a blue moon. But when you need it and it's there, then it's like, oh, here we go. And that's what makes me think of this is it's like, it's not something that's going to happen every day. It's not going to happen, you know, maybe it happens once in a career. But knowing that information, knowing that it was there, knowing that that's a possibility and that's an option, it's like, okay, we can do this thing. And in this sense, it's not, you're not buying a tool. You're following through with the procedure that somebody else did. And hopefully if they did take good enough notes that you can replicate that same process and maybe fit it for the situation that you're in.
It's kind of like having a parachute. You only need it once.
True. It's very true. Very true. That's a great one. All right. What are some of the other comments? Let's get to the heart of what everybody wants to know. What do you think about landman on Paramount?
I watched the previews of that and I've thought, oh God, Hollywood's at it again. I have not watched the show. I will, but I haven't watched it yet. But calling a landman somebody that's out on a rig, come on, I know what a landman is. They're very good sales people out there buying up land for you to drill on. But they couldn't call it the driller man.
Yeah.
You know, it just wouldn't work. So Hollywood came up with
They couldn't call it the
Who
gauger.
knows?
Yeah. Couldn't call it the gauger. Brian says, oh, that's great advice. Experience require the experience, not the time. Clearly detailed experiences usually come from those failures. So great. Thank you. Oh, Brian, thanks for tuning in and watching the show. I appreciate that. Cruz, who's been on the show before and I don't know how interested you in this, but did an absolute masterclass on whipstocks.
Yep.
He did. I tell everybody that if they want to know anything about whipstocks. So Cruz's episode there. So, George, it's becoming increasingly common for potential customers to inquire about failures and how we've addressed them. They also often ask if any design changes were implemented as a result of those failures. So yes, at least in the fishing and remedial world, we are discussing failures more openly and explaining how we've responded to them. Hallelujah.
I haven't heard a lot of detail on that. I've heard a lot of people were talking more about failures. All through my career with Amoco, BP, Rimrock Energy for 1 year in the Barnett Shale, had a ball that time, and then 9 years with Apache, and then some with Viking Engineering, and I'm on my own now. But if a salesman walks in or a tech representative, et cetera, walks in, starts telling me all about a tool, I ask, okay, where's it failed and why? If they tell me it's never failed, I'm real polite. I don't even go out to lunch with that brand, and I go on. But if they can sit there and tell me, okay, it failed, this is the reason it failed, and this is either a personnel change or a tool change that made it successful afterwards. And it's not always tools. Sometimes it's the applier of that. It's just wrong in terms of what they've done. So that's what you got to be aware of is I want to know where you failed and I want to see how you fixed it. So that's basically what they're saying here. And it's that I agree with it 100%.
I'll get on my soapbox on this one for a second. This is something that I have consulted with numerous companies on and said, in the MWD world, there's no such thing as an MWD tool that doesn't fail. They're all going to fail. Now, it may be, 98% reliability, 99% reliability, could be 0.999 or whatever, but it's still going to fail. And I've always said, just go in there and say, look, this tool's going to work, but if and when it does fail, because it will, then say, this is what we do with failures. Having that set procedures in place to be able to say, after it fails, you're going to get some level of notification back within X number of hours. We'll do a full investigation. We'll get this back to you. And then at, 14 days on, if we haven't completely turned everything back in, at least we tell you we haven't figured it out, but we're continuing to be able to investigate.
Yeah.
And I think that's the thing that most engineers, especially in manufacturing style drilling, or even not even just drilling, but just manufacturing style operations, where it's so quickly repetitive to where by the time you're getting the failure report back to them, you've already drilled, another 2 wells or something. That in that you are working towards being able to get that feedback loop faster and get information back to them, even if it's inconclusive. There's still the fact that you're communicating it back to them. I don't know why more. If I was the head of a company, I would put our failures on the front of our webpage and just say, this is what's happening within reason.
Yeah. One of the things you're going to go on, measurement while drilling or any other tool that's out there is there's conditions that you don't use that tool in. Be upfront about that. Is it a depth? Is it a deviation? Is it a fluid? Is it a rock issue? But find where your tool works and where your tool doesn't, and stay away from the does it. You stay away from failures to an extent. But it's going to be learned by trial and error, but learn from your errors. So there's some places you just shouldn't use some tools. And it gets back, I'm doing a little work now with the Forge project in Utah on geothermal energy. And when they had a bunch of national laboratory scientists looking at this, and they were just calling out, okay, this is the spec we need, run this tool in there and let's test it. And the first couple of those I saw were that somebody in the supply industry didn't understand that geothermal wells are over 400 degrees and they cook most seals. And I've got some pictures of that again that I won't share, but there's a lot of those cases of pick where you want to use these tools, etc. And by the way, geothermal is an up and coming area where a lot of oil and gas companies are going to find some niches. We've seen some successful testing of this by putting 2 wells down, fracturing between them, and pushing water from one well to another well to harvest the heat that's in that rock. Now, the wells are going to need to be long with a lot of connections, and the rate of harvesting will slow down as the temperature is cooled off, but the rock will gradually raise that temperature up again. There's a lot of things that are interesting there, but first thing you learn is there's some places you do not use your particular tool if you're a salesperson or a technical support person. But then I rambled a little bit there, but just keep your eyes out on some of those things, because high temperature materials are being developed that may make its way back into the oil industry, because some of these things have been very, very successful.
That's amazing. So one of my friends is actually at that. He works at Sandia National Labs.
Mm-hmm.
And actually told me the other day that he made it onto your website and was able to download all your stuff before everything got taken away. Just a funny little note there. All right, we got some other ones. If you're not messing up, you're not pushing the envelope. So good, George. We often learn more from our failures than our successes.
Absolutely.
How can we make the culture shift across the industry?
You know, one of the ways to do it, instead of just celebrating your success, study it and see what worked that had not worked before. And then you can communicate that. I do believe that SPE has a place there, some really good papers, especially for reporting your successes. But I want to see more detail in overcoming something. What did you change to make it success? And then be clear enough in your description of it that somebody else could pick that up and apply it. I know there's a lot of talk about intellectual properties and sharing information like that. And I did file a couple of patents, and I got a couple of patents. But a company makes more with new technology that will work in their application. They typically will make more on their own wells than they would from royalties. And if what they're doing on their wells is adopted, then probably the tools will get cheaper. So there can be some successes. Go ahead and patent it if you want, but share it at a low cost or no cost, and say, hey, your only cost for using this will be telling me how to make it better.
I have seen some companies do that where they just want to see the technology exist, and they want to see it proliferated through the industry, because they know then that it will have failures, it will do certain
we'll
things,
have improvements,
and then the maturity of the technology will advance faster than if it's just used on their 5 or 6 wells versus on everybody's wells.
Well,
But if they're the ones with the patent, then they just want the sweetheart deal.
yeah, well, we're getting close to 1 million wells throughout the world, if not over that. And you come back, and I'll come back now into the realm of production.
Yeah, that's something I wanted to talk to you about.
Over 90% of land-based wells are artificially lifted. And it may be by choke gas control. Most of them are rod pumped. Then you have the submersible pumps, and you have the gas lift pumps. And there's others such as jet pumps and other types. There are 2 or 3 of them that I can't even remember what they are. But operating those to an optimum point is important. First time I went up to North Slope, we went through a room where 2 engineers were working there, and I think they switched off with 2 more at night. They were looking at the lift of wells and what they could change: pressures, location of the valves, operation of the valves. They were doing that every time. The bottom line there is they have a 15% production increase as they continue to optimize their lift systems. Now, there's a lot more rod lift wells than anything else, especially in the contiguous area that we work in.
Yes, sir.
And, there's 100 things that can go wrong before you get something going right. The biggest one, I think, is some of the corrosion and scale and paraffin issues, but the other ones right behind that can be gas interference, which is nothing more than knowing where to set the bottom of that pump in relationship to the perforations. And when the field foreman starts doing that, he can see the uptime and the production stays up. That's something that it's well known, but it isn't practiced. So it isn't something new that somebody is teaching. It's spreading the word about, hey, let's take a closer look about how we're producing our wells, because you're looking at the lift system, you're looking at the flow system. Where are the pinch points in the flow system? Is it low permeability? Is it plugging of the fractures, not using enough proppant, not getting a big enough fracture? Is it tubing too small or too big? And you get up to the wellhead, people put a choke on that wellhead and say, okay, this is going to work, and go away and never redo that choke. Well, I used to ask when I was teaching at the University of Tulsa at night with Kermit Brown's course, I said, okay, this is a gas well that's got water in it, and we want to lift that to the surface with the expansion of the gas and the bubble lift. Hindered settling is what they call that. And say, okay, I want you to develop a system for roughly adjusting the choke setting, and here's $20. What are you going to do? Basically, you go down and you buy a thermometer and a roll of duct tape. And you put the roll of duct tape, or put the duct taped thermometer on that wellhead, and then you start adjusting the choke until you get maximum heat coming up. That means a lot of the heat generation of the water is coming off, and it's being lifted out of that well. Trade that with a couple of shots from the top to find the liquid level, and you can optimize that type of a choke setting. You have to move it a little bit, but it'll work. All right. So there's other things like that. I learned that from a field foreman. So basically, and he was
Hope somebody's documenting all this.
Fooling around with dropping soap sticks, and he came up with an automatic soap stick dropper that would look at the pressure of the well. When the pressure started decreasing because the water leg was building up, it would drop a soap stick into the well. vertical wells, of course. And you could see it unload. And it became very, very good. You say, okay, I want to use that in deviated wells. I came up with the idea of just making round balls of of foamer, just letting them roll around to where they would and get foam to come up to the top. The kickback, what I learned from that is, yes, that will work, but you better tell your facilities guys to have some defoamer. Otherwise, you've got soap suds all over the location. I did that.
So was that an email? Was that a phone call? Tell me the story behind that one, because I kind of hear that.
Well, it was an irritation. I'll put it that way. But it's one of those, hey, if I don't try it, it's, and it was just one well, and they came back to it real quickly. They weren't spreading anything but some water and soap suds on the location, which was cleaned up fast enough. Fortunately, it was relatively fresh water. But it was absolutely hilarious on some of the things you get into. I mean, we were trying to foam wells down in Trinidad, and the lab work just worked perfectly. And then we tried to make it work in Trinidad, and it created an emulsion that shut the treater down for about 2 days. I was very unpopular again. But you got to make these things. You can't get ahead if you can't make a mistake every now and then. They put up with me. They asked me down 2 or 3 times to try to fix things on sand control. So, yeah.
I can only imagine just driving up to location, and it looks like, somebody's poured laundry detergent in a fountain.
I've got a picture of it. Coming out of the top of that tank and just going everywhere.
Please share that. Please share.
If I can find it. I have to go through a few slides to find that. Oh,
Through one of the thousands of PowerPoint presentations.
Yeah. Well, of slides. I probably have 200 or 300 presentations, but thousands of slides. But it's fun. It's fun. And this is another thing that I'd tell anybody listening here. As you really learn something, capture it, put it in a form that you can share it with. And that's how I got to 14,000 PowerPoint slides, is actually just putting these, and some of these presentations have 5 slides in them, because that's what it took to explain it. And maybe another one, I've got one that has 1,000 slides in a presentation. It's a 6-day school.
Oof.
Or a 5-day school, excuse me, that I used to put on when BP, Amoco and Chevron had an agreement and a training school. And I'd do some of those. But it ranges all over the place, from anything from, I come in after the drilling of the well, I've got them on cementing, perforating, kill fluids, frictions, elimination. You look at the number of friction points, pressure loss points are coming up, and you go through the formation, the perforations. And by the way, 12 shots per foot of a 0.6 of an inch perforating jet in 7-inch casing will only open up about 4% of the actual casing wall. And we had wells offshore that the perforated casing was a choke, a downhole choke on the system. They would flow 30,000 a day, and it was a choke. So don't think you've got all of the answers at any point. Just have your mind open to learning.
Wow. Never would have thought that your perfed holes would be a choke for the well.
Yeah. That's why open hole completions work like a charm in some areas. Gave you a lot of headaches too.
Yeah.
But you could do them.
Man, I would love to have a well where it's where there's that much. I started investing in some wells, about not last year, the year before, so 2023, and so much more of this, because so much of my career was focused on the drilling side and directional drilling, MWE operations at that. So, they're still, running casing, cementing, but we hit TD and then we get the tools out of the hole. And I'm like, we're out of there. I've still, to this day, still have not been on the rig floor during a casing running operations. Obviously, there's a lot going on, but I've never been able to see it happen and understand it. So now, still hasn't happened yet, but now like starting to see things like flowback, seeing, perf, completion, cement bond logs, knowing about, changing out the chokes and about uptime on wells, because I've got one well that's done really, really good, but it's had some downtime in the last year. And it's like, it probably would have been a lot closer to paying off had, it been running during that time.
Well, you got to know your conditions, but a decrease in runtime is the first thing that says, hey, something is changed. I've lost pressure. I've lost permeability. I have lost ability to lift. It tells you that something is different. Now you can take it and look at the decline, and that decline will come down pretty smoothly, and then it starts jumping around like that. Okay, you got a deliquidification problem here because the gas is not lifting, or the lift system is not lifting. And there's a lot of different things you can do, and especially when you're switching from a vertical well to a deviated well. You've got to have a lift system that is probably going to be a 2-component lift system. You need one to take that horizontal flow, bring it up high enough to where the liquid or the lift system above can start lifting the liquid before it has a chance to roll over and go right back down into it, because your gas is going to break to the high side of the pipe. And then horizontal up to about 15 degrees from vertical, your gas is breaking to the top pretty fast, and it may not be lifting your liquids. You need a sucker rod pump above a downhole liquid separator, above a tailpipe of reduced ID that goes down into the well to about 85 degrees. I mean, this has been proved out. There's a lot of different systems that do this, and they're poor boy systems in some of these cases. I know guys that have done it with a couple of different sizes, one crossover for your tubing, a couple of cup packers, and a small, basically it's a separator down hole that vents the gas up and vents the liquid up to the rod pump that sits right above it.
Simple works.
It works very well, in fact.
Good to see. All right, let's see if we've got some more questions there, Eric. Great tool for sharing drilling problems is myspread.com. I've heard of that one before. Eric, again, failures, incidents, that's what I'm usually facing when hired as a freelance fluids and cementing expert for litigation, dispute mediation. But then, of course, everything is covered by NDA. So many great stories out there covered by NDAs. Drilling teams are almost always pushed to their limits in terms of workload and have very little time for lessons learned.
Agreed. And particularly, the cementing guys are in that same boat. Get it done, get it done, get it done. And if you don't get a good cement job, you're going to have trouble with that well.
All right. Well, I think that's all of the questions from the audience there. Well, let me ask you this, George. Is there anything else that you would like to be able to share with the industry? Anything that we haven't asked you yet?
I can tell you that I had a fantastic time in the 54 years that I've been doing this type of stuff. But it's really, really nice to be semi-retired because I've got a little bit more time. No, I've loved it every step of the way because I am an infinitely curious person. And if I see something that isn't working or is working, I got to find out why it didn't or why it did. And I have the time to do that now.
What kind of projects are you looking for?
I'm not even looking for something that has a long duration. I typically don't even charge for, I won't charge for a telephone call. I don't do legal work because I don't like those NDAs. I want to be able to talk about something if I've learned about something. So that one's just something I just back away from. I have a guy that, a friend that does legal. He loves legal. He loves to eat lawyers, and he's quite good at it. And I just refer everything to him, and so I'm done. So I just want the problems that nobody else has solved yet, and might be hard to solve, might be impossible to solve, but it would be fun to solve it. And that's what I'm doing right now. I'm having a lot of fun.
Anything interesting that you've worked on recently?
Well, the geothermal is. I helped recently this last year of a company that was trying to bring on wells but having a water influx problem, and made a few suggestions there about water control. And I've got to tell you that the most successful workovers that almost anybody will do in a field in terms of added production will be changing the lift system, stimulations, etc., and it goes down. Cleanouts are marginal. Water shutoff is usually a waste of money, because unless you know how the water is moving and why the water is moving and with what the water is moving, you're probably going to damage your production or just spend a lot of money and get nothing. So, and I worked in that for a while, and finally I just said no more, because the only successful water deal I knew was a friend of mine in the Elkhorn up in Wyoming. He had this reservoir that started to produce a lot of water, and they put it on injection and just produced a tons of water. Well, okay, you've got fractures in the reservoir. He spent, and this was back in the 80s, where oil was about $10 a barrel. His company let him spend $120,000 for a tracer study to figure out where the big fractures were, and then they put a material in there that it sets up like a hockey puck in fractures, plugged the fractures, and brought the field back up to a financial point where it was worth keeping it. So things like that, pick your battles. I don't want to fool with water shutoff. It's too difficult to do because you're going to spend a fortune figuring out where the water is coming, unless you get lucky and just find a leak or something. The things that can be cured easily, lift systems. And in these horizontal wells that we're getting into increasingly, it's that dual lift system that you can put in. And there's multiple types of things. You can put some of these systems will go to about 20 degrees, but if you're ever thinking gas lift is effective, now gas lift is great because it'll lift solids up to the top without too much problem. But if you tilt that well over 5-10 degrees, that gas is going to break, and you're going to have to put a lot more gas in there to get into turbulence. And when you do that, it holds a back pressure on the well, and you have trouble completing or have trouble producing it. So there's a kickback, a little bit of, backslap on almost all of these things. Just got to learn where they are and what they're doing. But this is the type of thing we need to be sharing through the field people, because they're the ones that see it. They're the ones that can probably modernize it or just optimize it and get your wells online better.
Excellent. It's good stuff to be able to know. Got a comment there. Curiosity may have killed the cats, but it also curates the goats. Thanks, George. Wow.
I like that one. I'm going to use that one.
There we go. That was awesome. All right. I guess it's that point in time we got to give away a drill bit. Add that one up to the stage for everybody that did the hashtag Gibson. Going to get themselves a drill bit sent off to them. We'll see who the lucky winner of the day is. I've seen a couple people that have already won before, so hopefully we'll get ourselves a new one. Muhammad. All right. Muhammad, you are the winner of a Gibson Reports 3D printed drill bit. We'll get that one sent off to you. So send me a quick message there on LinkedIn, or you send it over to Tracy, whomever. Tracy will be the one handling everything. So if you send it to me, it'll just go straight back over to her. So, George, thank you so much for being here.
You're
Need to get
welcome.
you together with Scott, and maybe we'll get Scott, Rick, you, a couple other guys and gals together. Maybe we'll have the train wreck session from you guys. To be able to all get together.
That'll take 2 cases of beer.
I can finance that portion.
And all the folks that I've seen the name flash up on the screen, I've recognized a lot of you and worked with some of you. Thank you.
Yeah, thank you guys for tuning in. We really do appreciate it. Awesome being able to have you here on the show, George. Can't wait to have you come back again. I really enjoyed learning a lot, and
Well, I want to do one on the differences between high temperature oil wells and high temperature geothermal wells, and some of the lessons that have been learned in tools. I'm going to see if I can get that cleared with the Forge project, and maybe we'll do that in 6 months or so.
All right, you guys heard it here. Be able to get George back on the show. Thank you so much for being here, guys. Next week, next week we've got, who is it on the show, Tracy? Jason Isaac, former Texas State representative, who's now doing a lot of things in the oil and gas political space. Just love to be able to have those perspectives, to be able to come on here and talk about all the different things that our industry touches. So I guess that's it from me, guys. Have yourself a wonderful weekend, and as always, know your industry.